Question number 12. A solar panel has a surface area of 0.2 meter square. Area is given. The efficiency of the solar panel is 30%. Eta is given. At one instant, radiation intensity at normal incidence of the panel is 0.15 kilojoules per meter square per second. What is asking here? Radiation intensity. What do you mean by intensity? Intensity is power by area. Now, what is it given here? So this is given by 0.15 kilo. Always remove the prefixes and expand it. It's always better. But 10 cube and joules per meter square per second. The joules per second is nothing but your power, and this area is nothing but square meter. Okay, so now it is very clear for us. Intensity is given. What is the power output of the panel? Okay, when power output and efficiency are given, then immediately recall the formula. Eta is equal to output power by input power. Okay, so he's asking you the output power. Output power should be equal to eta multiplied by input power. What is the value of eta? Eta is nothing but your efficiency, 30%, which should be 0.3 multiplied by input power. I do not have an input power which you can calculate from here because intensity is given. So I will write the power is equal to 0.15 into 10 cube multiplied by what is the area? 0.2. 0.2. So this will give me, so how much is it? So if I take 10 from here, this is 2 into 0.5 is 3. 0.3, this is 30 watts. This is 30 watts. So here, write this as 30 watts. Finally, I get this as a 9 watt should be the answer. 9 watt, 9.0 milliwatt. Many of them, by mistake, they do this one. So take care. So this should be just 9 watt. Answer is C.